Hey guys, welcome to day 75 of Codeforces Every Day until GM. Let's just jump straight into problem solving today. I was going to do this problem, but then I realized I have just enough time to record a video today, so just jumping straight into it. Let's read the question. Turtle gives you a string S consisting of lowercase Latin letters. Turtle considers a pair of integers ij to be pleasant pair if and only if there exists an integer k such that I, k, j, and both of the following two conditions hold. So the conditions are sk does not equal to sk plus 1. So that means the current value does not equal to the value after it. And the current value does not equal to the chosen value, or the next value does not equal to the other chosen value. Alright. Besides, Turtle considers a pair of integers to be good if and only if si equals sj or ij is a pleasant pair. Okay, so there's good pairs and pleasant pairs. Good pairs are, or like the si equals sj thing is pretty intuitive, but pleasant pair is kind of strange. Turtle wants to reorder the string so that the number of good pairs is maximized. Please help him. How do you think about this question? Okay, so this is the simplest case, right? Si equals sj. I think I need a whiteboard for this for sure. In the first test case, 1, 3 is a good pair. It can be seen that we can't reorder the string so that the number of good pairs is greater than 1. BAC and CAB can also be the answer. Okay, why? Okay, let's just test why ABC is a good pair. So if it's a pleasant pair, it's automatically a good pair? Exists an integer k such that I is less than or equal to k, which is less than j, and okay. Or if and only if. That means exclusive or what? If and only if this or this. What is the, okay, exclusive or? If true only if proposition is if and only if that two statements are equivalent and have the same truth value, both true or both false. P if and only if Q. That's not what it's saying. P if and only if Q. I think it's, this is P if Q or R. So it's like P if and only if Q, but it's like this. Okay, so I think that's how this is saying. So this is still either or. This doesn't change. This is saying if SQ is SI equals SJ, R is pleasant pair. So now I'm thinking, no matter how you rearrange a string, condition Q is always going to be the same, right? Because it's like just combinatorics. Like if you have A, B, 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 this is one good pair, two good pair, three good pair, right? But if you arrange it B, A, B, B, it's still 1, 2, 3. So like we can kind of ignore this condition, I feel like. Okay. Now what if, now okay, say I was given like ABC I can reorder anyway. What about ABA? Like we can also have AAB, right? But this condition doesn't matter. It will always give us one, at least one good pair. Now, what about AB? Okay, we should probably AAB. This is a good pair. This is a good pair. Now let's look at AB. Is AB a good pair? I is... No, AB is not a good pair simply because... Well, this condition's true, right? Because the only possible I is this, which means this is J. SK, well, this is also K, right? And SK doesn't equal to this, so this is true. SK does not equal to SI, though, is not true. So this is not a pleasant pair. Now we have this. Let's get rid of these. Where this is I, this is J. So K can be either of these. I don't think this is a pleasant pair either. Because if I choose this as K, then sure, this is true. But then we feel SK plus 1. SK plus 1 is B is equal to SJ. So this is not a pleasant pair at all. Because the second one is, if I choose this as I, then SK will be equal to SK plus 1. So this only has one pleasant pair. This one, however, if we choose I, J, and then this is K, this is I, this is K, this is J, doesn't work because I equals K. Same for this, because I equals K. So this one only has one as well. right? So this doesn't tell me anything. We need to look at either a longer string ABC. Is there like any value in looking at ABCD here? Like this just won't matter, right? Because this has it's like as long as they're not adjacent, they're pleasant pairs. Right. So I think like if we were to add an A in here, how does this change? Let's do ABCA. Like if we have ABCA, let's do AABC. This is one pleasant pair, they're adjacent. This is not a pleasant pair like we defined earlier. This is a pleasant pair because we can pick B as K. And then this is a pleasant pair. And then this is not a pleasant pair. So this would have 3. Then what about like ABCA? This is a pleasant pair, or a good pair. This is good. This is good. This is also 3. Right? Am I missing one? Because we can't look at adjacents at all. So no, no, no. Yes. 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 I think this is right. Also 3. A, B, A, C. This is last combinatorics, right? So yes. 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 It's just 3 no matter what. I don't think there's any value in looking at 4. What about 5? Maybe I should look at this case, right? Because 1, 2, 3, 4, 5, 6. They're saying we can create 6 pleasant pairs out of E, D, 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 F. So E, D, 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 F. Let's do D, 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 F. E, D, 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 E, F first, and then let's see what we can make out of this. Now, this is a pleasant pair. This is a pleasant pair. This is a pleasant pair. We got 3 out the bat. And then this is not a pleasant pair because of this. Or this, right? This is a pleasant pair, however, which means this is a pleasant pair as well. And this is a pleasant pair. So we have 6. 1, 2, 3, 4, 5, 6. Yes. And then E, D, 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 F would be, we have our 3. This is no good because K plus 1 is Sj, which means like all of these are no good. This is good though. This ain't it. So it really doesn't matter. Here's what I noticed. Like, if you have dupes, it really doesn't matter where you put them in the array. They will always output the same amount of pairs. Right? So shouldn't we try to stagger them? Isn't this like a valid thing we should try to check? Like, for example, DED. Like, I don't think it does anything for this case and specifically, but doesn't this logically make sense to try? Because like if you we can't check adjacency either way. Wait, hold on. I need to think about my logic behind this. Like, we can't do this. Wait, do we stagger them or do we smush them? Because if we smush them, then we can get adjacents. But do we lose combinatorics value? Let me think. It's obviously going to be 3 by default, right? Because we have this, this, this. Plus... this is a pleasant pair. We have this. We have this. And then we have this, 3. This also hits 6. So I need to try with, like, FG. D, 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 E, F, G. D, E, D, F, D, G. We have our 3 plus 1, 2, wait, look at this. 1, 2, 3, 4, 5. But 6. 6. Right? 1, 2, 3, 4, 5, 6, which is 9. Then if I did D, 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 E, F, G, we'd have our 3 plus this. Maybe this, this, this. 1, 2, 3, 4. This, this, this. This is 10. Right? So we want to smush them. Okay. Turtle. Let's try turtle. 6. They're saying this is bis. 6RTLET. Or URTLET. Right. We have 1, 2, 3, 4, 5. 6, 7, 8, 9. Okay, wait, hold on. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So turtle has 10, I believe. Or this version of turtle. This version of turtle has 10 as well, I think. Alright, but then squished turtle. It's 1, 2, 3, 4, 5, 6, or 6, 7, 8, 9, 10, 11. This one has 11. Why does this not have 11? Why isn't it TT? Am I misunderstanding? In the second test case, we have 6. D, 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 E, F is 3 plus 1, 2, 3 is 6, indeed. Codeforces is already bis. We have repeated E's in Codeforces. Count for 1 either way. I'm a little confused why I don't understand turtle. Good pairs is maximized, yes. So we should squish them. We should just, because we're never allowed to count adjacent pairs. I don't understand why this is bis though. I don't. Like, can we just dot sort and call it a day? Is the implementation trivial? Is that why this one's low rated? Because this does not feel low rated. This does not feel 1200 to me. Like, if the implementation is as simple as just dot sort, this would be rated lower, but it's 1200. This is hard. Okay, hold on. Let me think. Okay, I don't understand turtle at all. Okay, am I misreading the question? sk cannot equal to sk plus 1. Which means we cannot have adjacent pairs. But this says we can have adjacent pairs. Shoot, is that why? Turtle. If we have this, I might be tripping with this. Because this isn't valid, right? sk, well, no, sk, and then sk plus 1. So it is valid. sk does not equal to si. Oh shoot, sk is equal to si, right? So this isn't valid. This isn't valid either way. Which is why we don't get that bonus one. We have to use it. That's why it's 10. So, okay, now I'm starting to think this doesn't even matter. Like, this rearranging... I mean, obviously it does something. Because there's like versions of E. Like, this is just worse, right? So now I'm back to this theory, where you just intertwine them. Like this one, you want to do TUT, RLE. Like if you have repeating numbers, you should just intertwine them, because now you get this value at least. You'll never have adjacents. So we need a counter for sure for this question, right? And then we I think I need to split it. No, I don't. Great. What's the idea behind this? So after counting the frequency of every character, we should find the max character and then alternate it with the second max character, right? Or like if I have AAA, BBB, and then C. If I have AAAA, BBBB, if I have AAAA, BB, C, what would I do? AAAA, BBC. Is that it? I don't think it even matters where I put this last A. I think I can put it in the front and it'll do the same. because we're gonna have 1, 2, 3, 4, 5, 6, 7. Wait. 1, 2, 3, 4, 5, 6. Then we have 1. Okay, let me think. We should sort key value pairs. Let's see if I remember how to do this. Value key. We care about the counts more than the key. For key value in S dot items. And then we need to reverse it. And then if len a equals 1, so there's only one character, we just print. I probably should make a counter S variable. Just print S and continue. And then we can track a 2 print to array. What do I need to do? Sort by frequency, and then subtract the most frequent character and the second most frequent character, and then we had 5 A's, 2 B's, 1 C. We would want to alternate. Hmm. We just append them to the front. I think so. I think so. Like if we have like a character that's too large, we're gonna have to have characters next to each other anyway, right? Okay. Let me think. While A0 0 is greater than A1 0. So this should be checking while the greatest character is greater than the second greatest character. We should add the character to print. We append key. It's value key. So we should append A01 value. Wait. Is let me think. A0 0. Yeah, it's A01. Okay. Well, this happens. A0 So we're working with tuples. Tuples are immutable. One A 0 1. Okay, this should be right. And then we should sorted. This is quite a pain. Why did I do it like this? Now I need to pop the first index? Maybe I could use a Q or something. Q equals DQ A. While Q, call it Q. Let's just call it Q. Am I cooking too hard? Count pop left. And then we check if count equals 0. Do nothing. And then we to print dot append char count minus equals 1 and q dot append count char. I feel like I'm going in like 3 loops. We should just be able to print join to print. Right, wait, actually, what is to print here? Oh yeah, no, this is correct. This is correct. Strings. Okay. Is this correct? Turtle. Check this, right? It gives 10. But this gets 10. I don't get it. But I think the logic is right. I think turtle for specific. Turtle specifically because T is the most, and then yeah, I think this is doing exactly what I want it to. I just don't know. I can't prove that it's right. DDDFE. This is correct. Code forces. This is correct. Right. Let me see. OOEE CC. So it'll do OEC. Everything else, and then OEC. Yes, I think. Okay, I just gotta make sure. I just gotta pray that the logic works because I have no idea. Should work. Like, I can't prove my logic. This is so miserable. Like, I have this idea. I hope that I explained my idea well enough so that y'all get it, but I can't prove that it works. I definitely have to review this question. And we got it. Alright. We got it. We got it. Try to find bad pairs. Adjacent pairs, right? That's what he's talking about. Some of the bad substrings are AB, yes, AA, BB. Why is, because if K is A, then yeah, yes, this is correct. What if you select, okay, yeah, no, this is correct. You basically just can't have like repetitions next to each other, right? Like you can have AAAA BCD, but you can't have AAA BBBB CD. And then some good are alternating. Yeah, you can do the same string alternating. Yeah, we covered that. Intuitively, we should try to create a string that does not contain equal characters together. Yes, I mean, that was my logic as well. But where's the proof? I mean, I guess we got there, but I don't completely understand why it works. But okay, we got it. We got it. If y'all enjoyed this video, be sure to like and subscribe. I will see y'all guys tomorrow. Bye.